All right, so you probably know the basics of the CRAF method, those 5 core steps for implementation. But what if I told you the most important decisions you make happen before you even think about writing that first prompt? This is CRF Level 2. We're going to dive into the advanced strategies that make the difference between AI code that's a dream to work with and a total nightmare.
So yeah, the basic process is a fantastic starting point. But the real game changer isn't just about following the steps. It's about what you do before you even start. We're talking about making smart choices with your libraries, building cohesive configurations, and embracing a core principle that can actually predict whether your AI will succeed or fail. Let's get right into that principle now.
And here it is, the core idea of advanced AI implementation. It's surprisingly simple. If an API is a pain for you to use, you can bet the AI is going to struggle with it too. You know what I'm talking about? That clunky interface where you always forget a parameter or it takes 10 lines of code to do one simple thing? For an AI, that frustration gets amplified, which leads to slower work and a lot more mistakes. Basically, good design for humans means good results from AI.
What this really means is that before we even think about implementing, we have to test the ergonomics of our design. And this isn't just about what you like best. It's a critical step to set the AI up for success. And there's a really practical test you can run for this.
The technique is pretty cool. You just ask the AI something like this. Hey, design 3 different ways to use this API. Just show me what it looks like to actually use them in code. The AI will spit out a few distinct versions. You might get a really clean, chained method, one that's a bit more long-winded, and maybe a third that's, a little too clever for its own good. Then you just look at them side by side and compare them on clarity, how much code it takes, and just the overall feel.
And the results from this little test, they're often staggering. I mean, look at this example. The clean, ergonomic design was implemented in 30 seconds with 0 errors. The more verbose version, it took 3 times as long and introduced 2 bugs. The pattern here is just undeniable. Better ergonomics lead directly to better, faster, and more accurate AI performance. This one test can literally save you hours of debugging down the line.
Okay, so you've done the test, you've picked a beautifully ergonomic design. Awesome. But now, how do you get that into code without the AI forgetting everything you just decided? A classic mistake is just switching to your code editor and firing off tiny, isolated prompts. The AI loses all the context. The solution is what we call the hybrid approach. It gives the AI both the big picture map and the specific turn-by-turn directions it needs.
Here's how it works. First, you get the AI to summarize your entire design chat into one big design.md file. You save that right inside your project. Then, and this is the key, for every single prompt you write from now on, you add one simple instruction. Hey, consult design.md for context and to figure out any fuzzy details. That one little sentence is a game changer. It gets rid of all the guesswork and makes sure the code perfectly matches what you plan. Now, with our design locked in and a solid communication strategy, there's one last crucial step we have to take before implementation, and that's strategically picking our tools. This isn't just about grabbing your favorite libraries off the shelf. It's about setting the rules of the road for the AI. Because every tool we choose acts as a guidepost. A great way to kick this off is with a broad prompt. Something like, let's explore some options for our tech stack. Talk to me about web frameworks, language choices, testing, logging, and validation. The AI will lay out the trade-offs for you. Express versus Fastify for performance, Jest versus Vitest for modern features. It brings up things you might not have even thought about, and suddenly your role shifts from just a coder to more of an architect.
Let's take that classic debate, JavaScript versus TypeScript, but look at it through the AI's eyes. This choice has huge consequences. TypeScript's types give the AI a ton of rich context, which means fewer mistakes, but you get more boilerplate code. JavaScript is way faster for getting a prototype up and running, but it can be a bit of a minefield for the AI. So a good rule of thumb? Use TypeScript for production-ready systems and stick with JavaScript for those quick and dirty prototypes. The key is to make a conscious choice and then commit to it.
And all of this leads to a really powerful strategy. Instead of picking your tools one by one and hoping they all play nicely together, you bundle them into cohesive configurations. This is how you avoid building a Frankenstein stack, where libraries are constantly fighting each other. The goal here is complete harmony. By asking the AI to propose these bundles, you get some amazing options. For instance, a minimalist config that's all about speed and simplicity for an MVP, or a production config that's built to be robust and scalable for a serious system, and maybe a modern setup that's all about bleeding-edge performance. You just pick the one that fits your project's goals. It's that simple.
The differences upfront work makes is immediate. It's night and day. When you tell the AI, okay, build this feature using the production configuration, the code it spits out is perfectly consistent. It's properly typed, it uses the right logger in the right way, it even generates the matching test files. There are no mixed styles, no weird conflicts, no confusion. Just clean, predictable code.
So what does this whole transformation really look like in practice? Well, this isn't just about a feeling of things being better. It's quantifiable. Let's actually look at the data. First off, your mental load. By making all these big architectural choices up front, we see an 80% drop in the number of stressful, high-stakes decisions you have to make while you're deep in the code. You've already paved the road, so you and the AI can just focus on driving. Next up is speed. We're talking up to a 70% reduction in development time. And the reason is simple. A constrained AI is an efficient AI. When it doesn't have to guess which library or pattern to use, it can just build. And it builds fast.
And finally, just look at the overall health of the project. The old way might leave you with a Git history of 50 messy, confusing commits. With advanced craft, you get maybe 5 clean, purposeful commits. Library conflicts? They drop to 0. And the fidelity of your design goes from kinda close to 100% perfect match. All thanks to that hybrid document we talked about.
When you put all this together, it means your role fundamentally changes. You're not just a coder anymore, cranking out lines of code. You become an architect. You are crafting the precise constraints that guide an AI to a flawless implementation. It's a completely different way of thinking about building software. So that brings us to the final question you should ask yourself. Are you just building with a random pile of tools and hoping for the best? Or are you truly crafting using precise constraints to guide the process? Because the difference between those two is the difference between a frustrating mess and a perfect final product.